Hey everybody. So what happens if you can't get your engine to start? You got your tuned port Camaro and it'll crank but no start. Now, last video I kind of went through the general things about, how do you diagnose an old GM computer controlled engine. This one will be again pointed for tuned port injection, but a lot of the basics are the same for other cars. It won't be identical because every car has different sensors and different things, but let's start with it doesn't want to start, right? The first thing is basics. The basics are, it's just like a non-computer engine, right? You need spark, and you need fuel, and you need the right fuel mixture. It's got to be reasonably close. I say reasonably close because when you're cranking, when you're starting, you tend to have a richer than normal fuel mixture that lights off easier. On conventional cars with carburetors, you have a choke, right? And the choke richens up your fuel mixture. The folks who designed these early fuel injection systems, their thought processes weren't a lot different. They were trying to sell you a fuel-injected car to people who had carburetors before and had carburetor habits. So if you ever looked inside the software and looked in their routines, there's you would find a lot of carburetor language, okay, and thoughts. So if you have a carbureted car, for example, and you crank it and it doesn't start, what do? Well, you put your foot to the floor, and what does that do? On a carbureted car, there's a mechanism called an unloader. And if you read your owner's manual in your old carbureted cars, if it didn't start fairly quickly and you thought you had fouled the plugs or got it flooded, as they called it, you'd put the thing all the way to the floor, and the mechanism would pop the choke open a little bit, maybe quite a bit, depending on how it was set, and you'd get more air into the engine to dilute the fuel to hopefully get you a start. Well, fuel injection's the same way. There's an unloader feature, so if you're cranking and you're using light throttle, you should be able to start it foot off the throttle. Maybe it doesn't start, so you add a little bit of throttle to help. But if you go all the way to wide open and the throttle position sensor sees wide open, it goes, oh, somebody thinks it's flooded like their carburetor was, and so it turns the fuel off if you go to wide open throttle. And just while you're cranking, certainly not while you're on the road. There are little tricks like that that show up in these engines that you kind of need to be aware of. That's one, is wide open throttle when you're cranking will lean the fuel mixture out. And if you're having trouble getting it started, go ahead and try that, because you could have a fuel injector that's been dripping. You might have too much fuel in a cylinder. Usually I'll say on tuned port, on multi-port engines, the thing with those is if you had a bad injector, or you had one leaking, you had one cylinder fouled, the other 4, 6, 7, depends on your, I'm talking about, you have a 4-cylinder engine and you got 3 more cylinders to fire, or a V8 and you got 7 more cylinders to fire. But if you have one bad one, it may run horribly once you get it started, but the other cylinders ought to light off. Something ought to fire and get you started. And then you'd be troubleshooting, I've got a rough idle, whatever the symptom might happen to be. Second thing, when you're dealing with a start, is the oxygen sensor and all the control systems around closed loop and oxygen sensor are completely out of the equation. You don't have to deal with those. The oxygen sensor is cold. The computer knows that, and so it goes in and feeds a calibrated fuel profile based on the temperature, the sensors on the engine for temperature. On the tuned port, this is specifically a 1985 305 tuned port injection. This engine has what they call a cold start injector, a 9th injector. And so when the engine's below a certain temperature, that cold start injector should kick in and feed extra fuel to get you started. At a certain point in later models, they deleted that and they just adjusted the fuel curve so that all the normal 8 injectors would put in enough fuel. I can't answer exactly why they were having trouble with that in these cars in the early days, and they elected to pay the money to put in a 9th injector. But obviously something happened in development, and that was their solution at that time. This being Chevy's first port-injected V8, and 85 being the first year for it. The basics are you need to have fuel. So your fuel pump needs to come up. And you need to have fuel pressure. The second thing is you need to have ignition. We'll talk about that a little bit more in a second, but again, it goes back to basics. Are your cap, rotor, wires, is everything in good condition? Do you have spark? And do you have reliable spark? There are a whole number of reasons why that might be the case that you wouldn't. And as I said, cap and rotor, they can carbon track, they can arc over, and so when you're cranking the engine, you may not have spark. So those are the things just to think about as you're getting started. Do you have good fuel? Is your fuel pump coming up? If you have an intermittent no start, that one's even a little bit more odd. I'm going to go back through here in a few minutes. We're going to go over to the service manual, and I'm going to walk through and show you what the trouble trees suggest and what the service manual suggests for a no start and what things you should look at. I'll just say from a kind of a gut sort of thing is, if it's an intermittent no start, this is just my opinion from experience over years, is I'd probably be starting on the ignition system, and whether it's with you or not. But there's a list, and on this engine you have a mass airflow sensor in an 85, and the mass airflow sensor, if it's wrong, can cause you to have a no start. Any of the sensors on the engine could cause a no start. I shouldn't say any. The main thing is temperature on this engine. And you'll have a manifold temperature and you'll have a coolant temperature. But there's probably less, I'll say, computer diagnostics. The thing when you go to a start is, again, having the right fuel mixture. Did you spark? Will it light off? And is your, probably is your timing in the right place, spark timing and so forth. So that's kind of my intro. I'm going to turn around here and I'm going to show you the service manual, and we'll walk through and we'll discuss a few things. And hopefully if your tune port doesn't start, you've got some things you could go dig into. So this is the chart, A3A, and it's actually 2 pages. And this is where they start pointing you if the engine doesn't want to run. If it cranks but won't run. These are the pinouts on the ECM, and they show the wires coming out here to the distributor, to the high energy ignition module. These are the wires that come out to the fuel injectors, and it looks like there's 2 driver circuits, and so you would drive 4 injectors at a time, and they get powered off here from this side. You got fuses for each side that go through an instrument panel connector, 6-way it says, and then feeds out to the injectors. And something, and I brought this up a little bit in my last video where we're talking about diagnostics on the engine, but there are 2 things that the ECM can do for you just to troubleshooting. It can feed power, like it's doing here, right? The high energy ignition module's got a ground on it, and there's a ground that comes back into the ECM, but it's feeding signals out to the high energy ignition module. And there are other things here that will feed voltage to sensors and so forth. The fuel injectors are different, and there are other systems that are this way also. These actually are a switched ground. In other words, they don't send 12 volts out to the fuel injectors and have it grounded at this side. The power comes into the fuel injectors from the power side, and then the ECM grounds it. You can see the little symbol here for a ground. It switches a ground in and it pulls power the other direction. And so some things they call them pulling up, and some of them you're pulling down. You know, pulling up would send voltage out, pulling down would be sending it to ground. It's just the way that they choose to design the semiconductors and control the circuit. Won't run. Battery condition and engine cranking speed are okay. There's adequate fuel in the tank. Engine starts but immediately stalls. If you get that, it's called a hard start, and it's in the back of the manual, and we'll go over there and take a quick look at that. This is starts but doesn't fire off and run. You need to do the check engine light and make sure that you get a actually it would help to back up one and make sure that you do a code check and get a code 12, that it flashes a code 12 before you get going. But assuming your check engine light is on when you turn the key, then you need a tool. They got this one they call an ST125. You've probably seen these. It's a tool, a little light. You take off a spark plug wire and you put that tool, that light, between the plug and the plug wire. And you don't want the plug wire to arc into the air, because you can damage the module and you can damage things, cause arcing inside the cap. So you need to get one of those little tools. You can get them at Harbor Freight. I'll try to get you a picture of one. But you should really check spark on at least 2 wires. If you got spark on, normally if you get spark on one, it's enough, but if you didn't, then see if you got a spark on another wire. See if it's a single wire that's in trouble. This description applies to this chart on the right. So there's a test to see if the ECM is controlling the injectors with a test light. That's another one. You can get what they call, called a Noid light. They're injector tester lights, and you can buy a kit, again, down at Harbor Freight, fairly inexpensively, that you'll connect into the fuel injector harness to verify that it's working. You may need a pressure gauge. I've got a separate video out on how to measure pressure on the fuel system. Here are some comments that really I don't think are in the chart. One is, you could have an EGR valve that sticks open, which would cause you a lean fuel mixture. Now it's hard to get underneath this plenum to see if that valve is closed properly. On a most of the conventional carbureted engines, you can reach underneath the valve and you can feel whether the diaphragm is where it belongs. But that could be an issue. You may need to check for fouled plugs. If there's fuel on them, you could have spark and you've got fuel on the plugs and they aren't going to light. Throttle position sensor. This is the one I talked about before. If the sensor is stuck or binding and it's in the wide open throttle, it'll go into that clear the flood mode and turn off the fuel, and certainly then it won't start. Bad cold start injector if it's cold. You need to check the cold start valve. There's another chart. Defective MAF sensor, manifold airflow sensor. If it's bad, you disconnect it, and the ECM has a backup value, default value that it will try. And if you can get it to start, then that would suggest the airflow sensor is bad. There's one here where you disconnect the 4-way connector on the distributor. This is an electronic spark timing. If you disconnect that, then the electronic spark timing signal goes away and it'll go to a default. It says engine temperature below 30°C, 86 F, wait 2 minutes after the engine was last cranked, turn on the ignition, note the pressure. This is a fuel pressure test. So if you go down the chart over here, it says fuel's okay, fuel quantity, ignition on, check engine lights should be on. Ground that diagnostic terminal like I showed in the last video, which is ALDL, ALCL connector. You want to take pin B to pin A and make it flash, and make sure you don't have a code 54. If you do, then you go over and you look at the code 54 chart. Code 54 before we get too far out. Oh, low voltage in the fuel pump. So if you got a code 54, it says your fuel pump's not got power. So if you don't have that, then you check spark on at least 2 wires while cranking. If you have spark, then you go to an injector and you disconnect an injector connector and you put the test light on the harness and you crank and you see if the light blinks. If the light blinks, then you put on your fuel pressure gauge and you check and make sure you have fuel pressure. Then it says go see the diagnostic aids that I already went through for you. If your fuel injector has a steady light and not blinking, then there's some information here on how to check the circuit that drives the injector. And that could drive you to a faulty ECM or a faulty injector. And if you go to no light, then again there's a chart 3B. That's the next page. We'll go to that. If you don't have spark, then you want to check for battery voltage to the ignition system. And you could do that right at the distributor cap. And then you go do basic problem solving on high energy ignitions. You know, is the module bad? Again, cap or rotor. Now I'm going to change the page here to part B. If you don't have a blinking light on the fuel injector, then you can make some voltage measurements here. You know, is the light on, not light on? This is like detailed on the fuel injector drivers. Let's see if I can walk down that a little bit further. See test 7. So if you don't have a blinking light, the ignition is on. It says probe the harness terminals with a test light to ground, and the light should be on at both terminals. If you don't have a light, you've got an open in the injector feed. If you have one light on, it says due to injectors wired in parallel, there should be a light on both terminals. If not, the problem is in the harness to the tested injector. Assuming you got a light on both of them, reconnect your Noid light, disconnect the distributor 4-way connector, momentarily touch the harness connector terminal circuit 430 to 12 volts with a test light. Well, what's 430? Oh, 430 is the reference here that goes out to the HEI module with a test light. Test light only, it says. It says this test, number 7 here, test will determine if distributor module is not generating the reference pulse or if the wiring or ECM are at fault. By touching circuit 430 with a test light, a reference signal is being generated. If the test light at your injector then blinks, then the ECM and the wiring is okay. This number 8 is the discussion about whether the ECM is seeing a high TPS voltage. If you got through that last test successfully, you can go down and repeat the test to see that your fuel pump is running. And it says you can disconnect the TPS and then the ECM will use a default value and turn the injectors on. Now, you can also look at your TPS if you have 2 other choices. One is to, if you have a scan tool, is read the voltage. Otherwise, you can go into the TPS with jumper wires and measure it with a meter too. But following the trouble tree, that is the fundamental cranks and won't run. Now if I go to the back here and it says hard start, then there's a whole list. Engine cranks okay but does not start for a long time, or may start and then die. And then there's a list here: fuel pressure, cold start valve, TPS for binding, high resistance in the coolant circuit or the coolant sensor, faulty in-tank fuel pump, EGR operation, injector fuses, ignition system for proper output with the test light and the spark plug wire. Worn shaft, bad wires, bad pickup coil. Pull the spark plugs and check for fouling, gapping. Check ignition coil connections. If engine starts and immediately stalls, open the distributor bypass line like you would if you were going to set timing. If the engine starts and runs, it says replace the pickup coil in the distributor. If engine starts and stalls, disconnect the airflow sensor. And then again, if it starts and runs, replace the sensor. I mean, those are the fundamental things to have to go through. I'm going to hit a couple of other things here. The first one is, if you get Noid lights and need to test your fuel injectors, one of the fun things on these cars is the fuel injector connections can be a little bit difficult. And here's what the connector looks like. Okay, and it has a wire that goes around it. And what I don't know what I'll call the right way is to disconnect these. They can kind of be a bear. But I have a whole little set. You can get a set of 4 of these different probes, there's 2 different angles or 3 different angles, and there's a straight one. I use these for a lot of stuff. But if you've got one of these injectors and it's going to be plugged onto your injector, you need to be able to get underneath here and pull that wire back, lift it just a little bit from underneath and wiggle, and once you get one side off, you can go around to the other side and you can lift the wire. But that wire locks the connector onto the injector connection, and that can be kind of tough. But I found that was my best tool for getting things on and off. And go a little further here. Right down here in the back, I don't have the cover off, but you can see there are 2 connectors back there, a brown one and a kind of an off-white. And those are the connections for the distributor. There's a mark on the cap that one of those is the battery feed, and I want to say that if memory serves me correctly, it's the right-hand connection. So if you're checking for spark, you want to take, or if you're having issues, you want to check the voltage on that terminal with the ignition on. Are you getting voltage fed to it? If you get your Noid lights, these are the connections for your fuel injectors, and you can see the little wires down there on the side. You need to release those connectors and get one off, or get 1 or 2, one at a time probably, and check there. The comment about EGR valve, this guy down here, if I can see it, the gold colored device is the EGR valve under there. And normally if the EGR valve's in trouble, the car won't run very well, and you should set a diagnostic code. There is a diagnostic code if it's sticking and not working properly. But you can't say for sure. It's very hard to get in there to get a finger underneath it. But if you could, you can feel whether the diaphragm is there, and in some cases you can even actuate it. I think that's probably a less common problem. But when if you got a hard problem and it's hard to solve, you want to be able to catch everything, So that one's probably lower on the list, but I wouldn't rule it out. When I rebuilt this engine, I put a brand new valve on it because I figured the rubber diaphragm was shot after all the years, and I just didn't trust it. Now the last one we talked about the TPS sensor, and that's this one right here, your throttle position. So when you open the throttle, that sensor actuates, just like that. And you can remove it. You just lift this latch, and pop that dude off of there, and then that disconnects it. And you know, this one is, like I said in my previous video, this is the weather pack one, and I've got my little jumper wires here that I can connect my jumper wire into that connector. I've got 3 of them, and so if I wanted to measure with my voltmeter, I would use the little jumpers on here. But that's the basics. When you're trying to get one of these that won't start, you know, many of the systems don't come into play when you're cranking, as I said earlier. You know, the air pump doesn't affect anything. Just, you know, when you're cranking, make sure you help it with the throttle a little bit. You know, crack the throttle if it doesn't start right away. You could probably go as much as half. If you have spark, as it mentioned in there, go back and check the plugs and see if you have like one wet spark plug or all wet spark plugs, or those are the things that you work through. And normally it doesn't take too long and you'll find a clue. Is the ignition system putting out, or is the fuel system putting out? And there you're cranking. So anyway, that's what the service manual tells you. That's how you would walk through. I've got a no start. You know, what is it? And you kind of walk through that. If you find that you've got, you know, an ignition issue, you can replace the module, cap rotor, coil. I've had ignition coils that were intermittent before, and you would think it's just a big coil of wire, it can't go bad, but I've had my share of bad ignition coils, and they can drive you to frustration too. I'm not saying that is necessarily the cause, but it's one, right? And then you need to look at the feed wires and make sure that you have a solid 12-volt signal from your ignition switch up to your distributor, and connections back to the ECM. So here I'm going to show you, here's what a picture of a spark plug checker looks like. And you can see it just plugs into the end of the spark plug wire, and the opposite end plugs onto the end of the spark plug. You crank, have somebody watching it. And here's a picture of a set of Noid lights. This Harbor Freight kit is good for a number of different models. If you had a throttle body GM, I think it's got one in there for that too. I don't own one because I've never gotten to the need, but it's a relatively inexpensive tool if you have to get in and diagnose your fuel injectors. One more thing, there's in the diagnostics in the manual, they tell you to use a test light, and I've got a couple of these. I've got one in my toolbox. I have this little set here that, when I say set, it's because there's one for house voltage for 115. This particular one here is for 12 to 24. It's just got a probe. It's got a light bulb in it. It's got an alligator clip lead that plugs into the end, so you could either hook this to ground or you could hook it to power, and then the opposite end of the probe you know, goes in gently into a connector just to touch and see whether you get a response. So it's another way other than a voltmeter of getting a... The nice thing about a test light is it puts a little bit of load on the circuit where your digital voltmeter will not. Regarding the distributor, I'm going to show you a few of the parts and why they are important when we're talking about making sure that your computer controlled engine runs right. So in a GM high energy ignition, inside the distributor, this is the rotor. This is the one that I took out of this engine, and in principle, you know, this part goes a long time. But what you have to watch out for is all of these parts are plastic, and plastic can age, and you know, this mounts in the distributor with these two screws to a metal plate, and metal bar. And you're dealing with high voltage, 40,000 volts, maybe 50, not more than that, but typically in the 40s. And that high voltage wants to find a way to get to ground. And so, you know, when you've got this installed and you push this tab down, you're not very far away from the plastic and you're not very far away from the metal. And there are two things that happen. One is you could end up with a pinhole through the plastic down to the metal and it'll arc through. And you can also develop what they call a carbon track, which is it starts to arc over the surface, generally because it's been dirty or contaminated, or even when you have a lot of arcs inside the cap, which you do, there's a certain amount of ozone that is conductive. And in any case, it's possible to get from these terminals over to one of the screws is to get a carbon track and have intermittent spark. And while this one looked okay, I just said, hey, I'm putting together a new engine, so I put a new one in. But that's what you're dealing with under the cap. If you have one of these that has what they call the large cap, this is the large cap with the coil in the cap. And some of the cars, I think later on, went back to a small cap with a separate coil. This one's built in, and here on the end are the connections back to the car. So one of them feeds power, one of them feeds the tach, if I remember correctly. I'm going by memory. The coil here has connectors that feed down, so this one picks up the 12 volts. And then underneath, you'll see there are 3 more terminals, and those 3 terminals come off of what is called the radio capacitor, which is this one. So this is the radio capacitor, and you can see that it has this this connector, which this goes outside the distributor and this comes up and plugs in. And it's keyed so that it can only go one way, and it plugs into the end of that cap. So here's the cap. This will come up underneath and plug in, like that. And then, as I said, it feeds into the inside. Now on the cap, I just was talking about carbon tracks. Same thing with the cap. And one of the reasons that GM went to these larger caps was that compared to the old point-triggered ignition, the electronic ignitions had higher voltages, and they were trying to spread these terminals out to prevent cross-firing and to minimize the ability of carbon to track, because you can kind of get the same thing. You can get carbon to track, you know, down to the metal. You can get it to track across from terminal to terminal. It can penetrate the cap and go up to into the metal frame of the coil. The center spot is the terminal where the coil feeds power. That button feeds the rotor, then the rotor goes around and sends it out to an individual spark plug. And if I go, I don't know if I can get it out of here. There, you can see the high voltage terminal of the coil is on the bottom here, and it goes in through that spring. And when I did this, I replaced the coil, which is just under a plastic cap. You take the plastic cap off, and then you can disassemble the coil. You can lift these wires out. And coils are generally pretty reliable, but in my life, I've had 3 or 4 of them that have died. And it's a coil, as the word says, is a coil of wire. And it's very, very fine wire because it's a step-up coil. And you know, you've got a primary and a secondary, and you want the voltage to go from 12 volts to 40,000. So you need you need a lot of turns in the secondary, and the wire's pretty fine, and so it can have, when they manufacture it, it might get a bend or a kink or some little flaw in it. And then over years, as it heats and cools and heats and cools and heats and cools, eventually that copper will break and you'll have a loose connection in there. And if you got enough power, this coils will be intermittent sometimes, because if you have enough power, they'll arc across, and depending on where the fault is. But so if you're having trouble with your computer engine and it looks like it's ignition, you know, go back and pull that distributor cap. You got 4 screws to get it to lift off, and you have to disconnect those, and then you can work on the inside. The next deeper one is the module, and I replaced that too. This is the original GM module, and this one, being electronic spark timing, has more terminals. There are 2 or 3 different models of this module, depending on how many terminals you need to connect to the ECM. This radio capacitor is supposed to take noise out, but it also is the connector that connects into this module and feeds it power. So you want to make sure that's a good one too. And capacitors break down over time. So again, I replaced this one, just not knowing how good it might be. And again, you can buy these off the shelf and replace them. The third one is the pickup, and I basically disassembled and rebuilt the whole distributor on this car, and this is the original pickup. It's probably fine. These are less frequent to fail. If I was guessing, you know, just from experience, you know, modules are probably number 1. And then other things just kind of fit in. Coils sometimes. I've never actually had one of these fail. But the way you get spark on these high energy ignitions on this version is this is another coil of wire. And these terminals, there are 8 of them because you have an 8-cylinder engine. And there's a pole piece in the middle that's on the distributor shaft that rotates around. And as it goes past these points, it's also got 8. As they go past those points, it puts a pulse of current in this connector that goes out to the ECM ultimately. Tells the ECM it's ready for a spark, and the ECM goes, okay, I'm going to set the spark timing based on my algorithm, based on my software, and then it sends that out to the module to tell the module when to fire. If you want to know a little bit more, I think if you go back to, I want to say it was episode 36 of me getting the engine running, I've got a video posted where I went through all of this and explained how to take the distributor apart. You won't see me take the whole thing apart because I was already finished before I did the video, but I walked through the process of what it takes to replace all these pieces and show you how they fit in. Last one is spark plug wires. I replaced them. I made a comment in here about the oxygen sensor and how the oxygen sensor can be fooled by an intermittent condition and cause your engine to run more rough, or not run at all once it gets warmed up. This part won't affect how you start it. But if you have one bad spark plug wire, and these wires are usually, they're carbon core. They're not a solid wire. The carbon core is a suppression to prevent noise in the radio. But down inside there, the wire is actually not wire, but it's typically some kind of sometimes it's fiberglass, there are different versions, or carbon strands. So, you know, one of these wires is, you know, has like 10,000 ohms or something, and they can break down, especially if you're, you know, pulling them to get off the spark plug wire. If you have a bad wire and you get a misfire, and the oxygen sensor picks that up, it will adjust the fuel on all the other cylinders, trying to compensate for the misfire. So those are my pieces for show and tell, but that's what you would use if you come out. The trouble trees down here, you know, if you have trouble trees that you're running for trying to understand what it takes to troubleshoot the engine, and it says ignition is a problem, that's what you need to go through to make sure your ignition is solid. This part is the exhaust gas recirculation valve, EGR valve they call it. And there was a comment, you know, these can cause engines to run poorly, and in some cases may even cause an engine not to start. And it brings in, I don't remember which direction, I believe this is the feed, and this is the recirculation. It takes exhaust gas and meters it back into the intake manifold to each cylinder for emissions purposes. It's to reduce nitrogen oxides by reducing the peak combustion temperatures. And if it's done right, it actually can help you get better fuel economy because it causes you to crack the throttle a little bit further with the same amount of fuel, and it reduces the manifold vacuum or increases the manifold pressure a little bit and takes some of the load off. But anyway, and this is what that valve looks like. This spot here is where the temperature sensor goes, and the way the computer, the ECM, knows that your EGR is working correctly is it measures the temperature here at certain times because if the valve is open and flowing, this will be hot. The sensor picks it up and satisfies that the valve is opening. So if you took the vacuum hose off and said, hey, I don't want any EGR, you'd set a code because this portion would never get hot from the flow. And the risk is, see that you've got a metal diaphragm here, I'm going to push on that, and it has a hole, an orifice here, a feed orifice, but you can push on this and you can see that the pintle in the middle, right here, that pintle moves down and moves back, and that's how it meters. It also adjusts internally. It senses exhaust back pressure, and depending on exhaust back pressure, it will also change its opening somewhat. And gross changes in back pressure, you know, can affect the calibration of how this operates. You have to go down into the book and read the description. But anyway, if for some reason this valve stuck open and you had flow all the time, it would be difficult to start, and it would be difficult when you're driving on down the road. You would probably have a stumble or drivability problem. And again, I replaced this one because it was old, and it has a rubber diaphragm or a synthetic polymer flexible diaphragm underneath that metal, and it can again age and perforate, and so then the vacuum will pull, but it won't actuate properly, and that would be a bad thing. So again, while I had the plenum off and the engine part, it got a brand new one. I hope that helps you. See you again soon.